Hello class, in this lesson you will understand how to deduce the formula for the series of the first n terms of an arithmetic sequence. Okay, very good. So at this moment, or by now, I should have explained to you live that property about writing a certain series, right? Such as, for example, this, and then writing the same series in the reverse order and having the property of the following. If we add column by column, we're gonna get the same number, right? 1, 4, 5, 2 plus 3 is 5, 3 plus 2 is 5. So we always get the same result. Okay, we're gonna work using this property in order to deduce the formula, once again, for the series of the first n terms of an arithmetic sequence. In other words, we want a formula to calculate quickly the sum of the first n terms of an arithmetic sequence. So let's begin. I'm going to write this, the series of the first n terms of an arithmetic sequence, and I'm going to write down, in fact, such series. That would be a1 plus a2 plus a3 plus a n minus 2. You will understand what I mean by this in a moment. Let me just write this down. There you go. So why do I write in here n minus 2 and n minus 1? What do they mean? Well, clearly, these are the previous terms to an, right? If this is an, then the previous term should be written as a sub n minus 1, right? Just as 2 is 1 less than 3, and just as 1 is 1 less than 2, this just follows the same pattern. This is 1 less than n, and n minus 2 is simply 1 less than n minus 1. So we have the series of the first n terms of an arithmetic sequence. Perfect. And now let me write down the same series, guys, all of these series, but in reverse order. Since I'm going to write the same series, I need to write once again s sub n. The only difference is that I'm going to start writing from this term, right below this one. Okay, remember that what we have in here is all the remaining terms. Okay, this is red, etc. Okay, and it contains all the other terms that I'm not writing down. Perfect. So next, let's add these two equations. This equation, guys, it's an equation, right? And this other equation, let's add them side by side. I'm gonna add the left side of this first equation to the left side of this second equation. So I'm gonna get this, right? And I'm going to add all this side plus all of this side of these two equations. But I'm gonna add them column by column, right? I'm gonna add this and this, and I'm gonna enclose them in parentheses for easy visualization, right? Like this is the term that I get out of the sum of these two, and then the sum of these two, the sum of these two. As you can see, all I'm doing is adding the terms column by column. And then all the ones that are here, hidden from us, and then these two, and then these two, and then these two. Okay, perfect. Okay, very good, guys. That's all I did so far. Now, this is the the trick. This is the good stuff. Listen, we already agreed. We already agreed that when we do this type of process, guys, in a series, when you write a series and then you write it down again in reverse order and you add the terms column by column, like this and this to produce this, this and this to produce this one, and so on. What you get in here, guys, are all the same number. All of these things are the same. Even though they look different, like a1 plus an, a2 plus an minus 1, yeah, they look different, but they are in fact the same. They are the same. And if they are the same, what I can do is this. I can write them down basically in terms of this one. If they're all the same, I can decide for one of them, such as this one, a1 plus an, and say that this is the same as this, and this is the same as this, and this is the same as this, and so on. You see? So basically, I can erase this, all of this that is in here, and just substitute a1 plus a sub n, like this, right? Because they're all equal. Nice. Very good. Now, what's the next step? The next step is doing this. Realizing how many of these terms I have in this right side of the equation. How many of these do we have, guys? We don't have 6. We don't have 6. Remember that there are many more in here. So I know that you see 6 of them, but that's not the number of couples that you have. How many couples do you have? You have n couples. Why? Because each of these corresponds to one column. This one corresponds to this column, right? This one corresponds to this column, and so on until this one corresponds to this column. So how many do you have in here? As many columns as you have on top. And how many columns do you have? You have 1, 2, 3, all the way up to n. You have n columns. So you have n of these guys, n couples all equal to this. You have n of these things, of these numbers, of these parentheses. And I told you also before that the way to represent that mathematically is through a multiplication, right? So all of this is equal to n times a1 plus an. And this is clearly 2 times Sn. Finally, the final step is just dividing both sides of this equation over 2. Okay, so that we can isolate Sn, and we are done. We have found the formula to get the sum of n terms, of the first n terms of an arithmetic sequence. Bear in mind that. And we have to do only this. The number of terms, okay, multiplied by the first term plus the last term over 2. Now, in your booklet, you will see, guys, that this formula also appears in the following way. It appears like so. So what's up with this? Is this a different formula than this? No, this is exactly the same. And if you want me to convince you, let's just do the following. Look at this, an. Do we have a formula for this? For the arithmetic sequence? Yes. It's equal to this, right? Okay, so let me use this formula and plug this value in here, because that's in fact an. So I'm gonna use this and I'm gonna just substitute. So that's gonna be equal to n times a1 plus an, which is equal to this stuff. . over 2. And if you simplify what's inside the parentheses, you're going to get a1 plus a1 to be 2a1 plus the rest, n minus 1 times d. And you can actually write everything over 2 is the same as well. Let me actually do it like this. And in the end, you can just divide the first one by 2, and it's going to be the same. If you're not fully convinced about this final step, I want you to tell me in a moment. Okay, this and this are the same. So that's it. As you can see, we have finally arrived at apparently this other formula, but it's not a different formula, guys. These two are the same. They are the same formula, basically, except that in here we are using this formula to arrive to this other version of the sum of the first 10 terms of an arithmetic sequence. So that is the deduction, guys. I want you to study it. I want you to be able to do this process on your own and to arrive at each of these two formulas by this process of reasoning that we carried out. So this is how we deduce a formula on our own. And you don't have to believe me that this is true or this is true, because I have shown you the process, and I hope I have convinced you that this is in fact true. And that's about it, guys. Thank you so much. See you in a few seconds in the lesson.